Okay, so I'm going to start with number 6 here. I want to find the value of the variable. And then what I'm going to use is the grid and kind of still talk about the theorem. If you prefer to use the theorem, you could do that. But I'm going to set up my grid. Along the top, I have the small, medium, and then large right triangles. I could actually put that along the side. And then on the top would be the short leg, the long leg, and then the hypotenuse. So on number 6, here's the small right triangle, here's the medium right triangle, and the original is the large right triangle. So I can start filling in some missing parts. Maybe you take a look at the large right triangle first. This is the short leg of the largest right triangle. So that's an unknown. Okay, I'm just going to put a question mark right there. We actually don't need to find it, but this is the longer leg. So the long leg of the large right triangle is y. And then the hypotenuse of the large right triangle right here. It's made up of these two segments. So 9 plus 2 is 11. Okay. Then I can go to the medium right triangle right here. In the medium right triangle, this is the short leg. It's unknown. So in the medium right triangle, short leg, I'm going to put a question mark. That doesn't mean that this is the same as this. It's just an unknown. Maybe just leave it blank if this confuses you. Okay, but in the medium right triangle, what I have shaded in here, the long leg is 9. The hypotenuse is y. If you recognize, you could already solve for y here, okay? Because I'm using the lower right corner. The only variable I have there is y. Here's the proportion that I could set up. This basically gives you the proportion. You just need to make the fractions and then the equal sign. So 9 over y is equal to y over 11. In other words, this side is a geometric mean between 9 and 11. 9 times 11, 99. That's y squared is 99. So y equals the square root of 99. If you wanted to put that in the simplest radical form, the perfect square factor, the only perfect square factor of 99 is 9. And 9 goes into 99 11 times. Square root of 9 is 3. 3 square root of 11. But if you prefer to use each of the theorems, that actually follows a geometric mean leg theorem, because this leg of the large right triangle is the geometric mean between the hypotenuse, 9 plus 2, 11, and the adjacent segment. The adjacent segment is 9. So you really set up this exact same proportion. But again, I think most people would actually prefer to use the grid in order to find the missing side length. Number 5, you can do something similar. I can set up my grid. So I'm going to set up my grid right here. We have the small, medium, large right triangles, short leg, long leg, and then the hypotenuse. So in this diagram here, this is a small right triangle. Here's the medium right triangle, and then the large right triangle. So in the large right triangle, the only thing that we know is the hypotenuse. Here's the hypotenuse, the sum of 16 and 9, or 25. I'm not even going to put question marks here this time. I'm just going to leave those blank. Okay, in the small right triangle, 9 is actually the short leg. X is the long leg. We don't know the hypotenuse. Okay, so I'm just going to leave that blank as well. Then in the medium right triangle, here's where it might get a little bit difficult, but X is actually the short leg. Here's what should actually always be true as well. The long leg of the smallest right triangle should actually be the short leg of the medium right triangle. And that's what we have here. And then in the medium right triangle, we know the long leg is 16. We don't know the hypotenuse. Kind of doesn't matter because in the upper left corner now, we have our proportion. 9 over x is equal to x over 16. So then to solve that, we can multiply, 9 by 16, and then take the square root of that. So 9 times 16, I'm going to write it up here, is 144. That's equal to x squared. So take the square root. It's a perfect square. X is equal to 12. Okay. Or if you prefer to use the geometric mean altitude theorem, the altitude is the geometric mean between these two parts right here, 9 and 16, and that's really the proportion that we set up right here. We'll go over one more problem, and that's number 8, but I'm going to save that for the next part.